This is Kai Mercer. In the endless silence of deep space, between the stars that burn and the planets that orbit them, there are travelers, drifters that wander between suns. They are ancient, silent, and mysterious. Some carry the frozen dust of creation. Others are fragments of forgotten worlds. But every once in a while, one of these travelers passes close enough for us to notice. And when it does, it changes how we see the universe. On July 1st, 2025, the Asteroid Terrestrial-impact Last Alert System, or ATLAS, detected a faint object moving against the background of stars. The telescope that found it was located in the high deserts of Chile, one of the best places on Earth to watch the sky. At first, the discovery looked routine, another small body drifting toward the inner solar system. It was temporarily designated A1112-3Z, an unassuming string of letters and numbers that marked it as one more minor discovery in a crowded sky. But within days, astronomers realized that this object was anything but ordinary. Its velocity was too high, its trajectory too strange. When the data was traced backward, the path didn't loop around the sun. It came from outside the solar system entirely. That meant one extraordinary thing. Humanity had just discovered the third known interstellar object ever detected. It was officially named 3Y/Atlas. The designation means third interstellar, following in the footsteps of 1I/Oumuamua, discovered in 2017, and 2I/Borisov, spotted in 2019. Yet unlike those first two visitors, 3I/Atlas carried an even deeper mystery. From the moment of its discovery, something about it seemed off. Its brightness fluctuated strangely, as though it were tumbling in an uneven way. Its shape defied easy explanation. It wasn't round, like most comets, nor elongated in a simple spindle shape. And as astronomers observed it, the object seemed to fragment, breaking apart without the typical outgassing that marks cometary activity. It didn't behave like ice sublimating in the sun's heat. It behaved like something else. In time, as the data was gathered, theories began to form, cautious, scientific, but also imaginative. Some astronomers argued that 3Y/Atlas was simply a brittle, icy fragment from another system, torn apart by solar radiation. But others wondered aloud, what if it wasn't? What if, hidden within that tumbling light, there was evidence of something greater? What if 3I/Atlas wasn't just a comet at all, but the broken remains of something constructed, a probe, a fragment of a vessel, or a messenger from another civilization, crossing the interstellar void for thousands of years before we happen to notice? To understand why that question matters, we have to step back to the very beginning, to 2017, when astronomers first realized that the solar system wasn't as isolated as we'd once imagined. That year, a small reddish object was spotted moving faster than any known asteroid. Its name was 1I/Oumuamua, a Hawaiian word meaning scout or messenger. Oumuamua was unlike anything we had ever seen. It was cigar-shaped, roughly 100 meters long, and reflected sunlight in ways that suggested it was flat or metallic. As it passed near the sun, it accelerated, slightly but measurably, with no visible signs of outgassing, no tail, and no plume of vapor. It was as though something invisible was pushing it. For months, astronomers around the world debated what it could be. Some said it was a fragment of a shattered planet. Others proposed a hydrogen iceberg, something never before observed. But one voice, that of astrophysicist Avi Loeb at Harvard, offered a bold possibility. What if it was artificial? Loeb argued that Oumuamua might be a piece of alien technology, perhaps a solar sail, a thin sheet of reflective material propelled by starlight. He pointed out that its acceleration, its shape, and its silence all fit the profile. The scientific community was divided. Many dismissed the idea as speculation, but others found it strangely compelling. Now, with the discovery of 3I/Atlas, the question has returned, sharper, louder, and harder to ignore, because once can be coincidence, twice perhaps, but 3 times? 3 separate objects from 3 separate directions, all with behavior that doesn't neatly fit our models of natural comets. Something, it seems, is out there, and we're just beginning to notice. This is Kai Mercer, coming to you live. Tonight, an event unlike any other in human history is unfolding above our heads. Astronomers across the globe are tracking an interstellar object, 3I/Atlas, as it closes in on Earth. Once a distant speck moving silently through the night sky, it is now drawing near at a velocity and trajectory that has captured the attention of every major observatory on the planet. At first, it appeared as just another comet, a fleeting visitor from a distant star system. But over the past weeks, as precise measurements came in, it became clear that 3I/Atlas was moving on a path bringing it unusually close to our planet. Its speed is extraordinary, faster than any natural comet previously recorded in the inner solar system, and its tumbling motion is irregular, unpredictable. Scientists are working around the clock to refine models of its trajectory, and the data is both astonishing and, for many, unsettling. Tonight, we are witnessing the first moments when humanity comes face to face with an object that originated beyond our solar system. The object is still far beyond the moon, but visible through powerful telescopes. Early images show a fragmented body, jagged and tumbling, its surface reflecting sunlight in fleeting glints. Observatories in Chile, Hawaii, and Australia are all tracking it in real time, coordinating to capture every nuance of its motion. Space agencies have confirmed that no impact is currently predicted. Yet the proximity of 3I/Atlas to Earth's orbit is unprecedented. The object's path is unpredictable, affected by outgassing from volatile materials within, creating tiny but significant thrusts that alter its course. Every observation is critical. Every second matters. Amid the tension, scientists are also analyzing the object's composition. Spectral analysis indicates a mixture of metals and silicates, not unlike an asteroid, but also a small component of unusual ices rarely observed in solar system comets. These anomalies have prompted further scrutiny. Could this combination hint at a body formed around another star, or something even stranger? As I speak, observatories are reporting fluctuating brightness. The object is breaking apart in small fragments, scattering tiny particles along its path. Radio telescopes are listening intently for any signals, intentional or otherwise, though none have been detected so far. Still, the very idea that this object is passing through our neighborhood, a traveler from interstellar space, is breathtaking in its magnitude. Public interest has skyrocketed. Sky watchers and amateur astronomers are attempting to glimpse 3I/Atlas, while social media is alive with images and speculation. Yet amid the excitement, scientists urge calm. Observations are precise, calculations are ongoing, and while this is extraordinary, there is no immediate threat. Already, plans are being made for potential spacecraft observation. Space agencies are considering fast response missions to study the fragments and composition. The knowledge gleaned from 3I/Atlas could answer questions about planetary formation, interstellar chemistry, and the conditions around distant stars. This is not science fiction. This is science unfolding before our eyes. Tonight, as I speak, Humanity watches a visitor from the stars approach a world that has never before seen such an arrival. And while the night sky remains silent to our ears, the object itself is telling a story written in light, speed, and trajectory. A story we are only beginning to decipher. For now, telescopes remain trained. Calculations continue to refine the path, and scientists across the globe are holding their collective breath. 3I/Atlas, once a distant curiosity, has become a tangible presence, a reminder of the vastness beyond our solar system, and the unexpected ways the universe can reach out to us. This is Kai Mercer, speaking live as we witness history in motion. Tonight, we are all observers of the unknown. And while the object moves silently through the darkness, one thing is certain: humanity has never looked at the stars quite the same way again. This is Kai Mercer, speaking to you live as the world witnesses a moment no human has ever experienced before. Over the past several days, 3I/Atlas has been approaching Earth at remarkable speed, an interstellar traveler now visible in telescopes around the globe. But tonight, astronomers have reported something entirely new: unusual signals emanating from the direction of the object, subtle pulses that appear to be patterned rather than random. For decades, humanity has trained its instruments to listen to the cosmos, searching for signs of intelligent life beyond our solar system. Tonight, those instruments are returning something strange, a signal unlike any natural phenomenon we've cataloged. It is faint, yet consistent, a series of repeating electromagnetic pulses that seem almost deliberate. Scientists are rushing to verify the source, triangulating readings from radio telescopes in Chile, Hawaii, and the Canary Islands. All point to the same location: the trajectory of 3I/Atlas itself. At first, experts cautioned against jumping to conclusions. The universe is full of background noise, solar flares, cosmic rays, and interference from earthbound technology. But as the data streams in, the signal is growing more distinct, more structured. Analysis of its frequency suggests non-random modulation, patterns that could be a form of communication, intentional or otherwise. Teams of astrophysicists and radio astronomers are working feverishly to decode it. From our vantage point, there is no visual confirmation of any artificial structure. 3I/Atlas remains a jagged, tumbling body, reflecting sunlight as fragments drift along its path. Yet the signals challenge everything we know about comets and asteroids. They are too regular to be natural phenomena, too coherent to be dismissed as cosmic background noise. Every pulse is a potential message, a cosmic whisper from the stars. Governments and space agencies have now joined the effort. Observatories that normally track asteroids and satellites are redirecting their arrays, listening carefully, recording every nuance of the electromagnetic patterns. Teams are running real-time analyses, checking for repetition, encoding schemes, and signs of intelligent modulation. The signals are faint, but unmistakable, a subtle rhythm in the chaos of the cosmos, pulsing from a body that has traveled light years to reach our solar system. Meanwhile, the public is beginning to take notice. Social media is alive with speculation. Amateur astronomers posting telescope images, enthusiasts analyzing raw data, the world collectively holding its breath. Yet scientists urge calm. Verification is ongoing. No conclusions can yet be drawn. And yet, for the first time in human history, the possibility exists that an interstellar object approaching Earth is not merely a fragment of ice and rock, but a messenger carrying information from beyond our stars. Astronomers are already proposing theoretical explanations. Could this be a natural phenomenon, Perhaps an unusual interaction between solar wind and the object's volatile materials. Possibly. But the regularity of the pulses, their distinct repetition patterns, defies current models. Could it be artificial, a probe, a sensor, a fragment of intelligent design? The notion is extraordinary, but it cannot be dismissed outright. Every scientist involved treats the data with rigor, documenting, measuring, and repeating observations. And as I speak, 3I/Atlas continues its inexorable approach. Its speed is immense, its trajectory precise, and every second brings it closer to Earth's vicinity. With each rotation, it exposes new surfaces to our instruments, and each new observation adds to the puzzle. The signals persist. Slight variations in amplitude and timing hint at structure. Patterns emerge, sequences that suggest information, complexity, perhaps intention. For now, we do not understand the content, or even the purpose of these transmissions. But they exist, undeniable, whispering across the void. Tonight, the human race listens as it has never listened before. Our instruments are poised, our scientists alert, and our imaginations engaged. 3I/Atlas, a visitor from beyond our sun, may have brought more than fragments of a distant system. It may have brought a message, a signal traveling across interstellar space, carried by a tumbling object that defies conventional explanation. And so we wait, recording every pulse, every fluctuation, every anomaly. As the object draws nearer, the world holds its breath, suspended between the laws of physics and the possibility of the unknown. Whether these signals are natural or artificial, benign or intentional, one thing is certain. Tonight, humanity is listening to the stars in a way it never has before. Across the world, the news of 3I/Atlas and the mysterious signals has sent ripples of excitement, curiosity, and apprehension. In Tokyo, astronomers crowded around monitors, eyes fixed on readouts. While nearby, students in observatories whispered in awe at the live feeds. In Europe, radio telescopes in Germany and the Netherlands worked tirelessly, cross-checking the signals with data from the southern hemisphere. Every pulse, every fluctuation, was being verified and logged in real time. Public response has been immediate and intense. Social media exploded with speculation, as both amateur stargazers and professional enthusiasts shared telescope images, signal graphs, and theories. News broadcasts across multiple continents interrupted programming to provide live updates. Citizens gathered in parks, on rooftops, and along quiet rural roads to catch a glimpse of the distant visitor. The sky, once familiar and constant, now held a sense of impending revelation, a tangible reminder that the universe is vast, alive, and unpredictable. Governments have mobilized. Space agencies from the United States, Europe, Japan, and Australia have convened emergency task forces, coordinating the world's most sophisticated telescopes and communication networks. In press briefings, officials carefully balanced transparency with caution, acknowledging the signals, but emphasizing that no immediate threat is posed to Earth. Yet behind closed doors, scientists and engineers are analyzing every possible scenario, running simulations on 3I/Atlas's approach, and preparing contingency plans in case the signals indicate something more than natural origin. Meanwhile, the public imagination has taken flight. Forums and online communities debate the implications. Is this a message from an advanced civilization? Could this object carry information, or even technology, beyond our comprehension? Skeptics caution against over-interpretation, citing cosmic noise and statistical anomalies, while others speculate about alien intelligence and the dawn of first contact. The tension between wonder and fear is palpable. A global audience united in awe, uncertainty, and anticipation. In observatories, scientists are working around the clock. Night and day have lost their meaning as teams parse terabytes of data streaming in from arrays of instruments. Analysts compare the pulse's timing, pattern, and frequency. Some see repetition suggestive of encoding. Others note irregularities that defy easy explanation. Every new data point sharpens the debate and heightens the suspense. The world is collectively listening, waiting, watching, questioning, as the interstellar visitor draws ever closer. Amid the excitement, live coverage from smaller towns and remote locations has added a human dimension. In Chile, the local population gathers in the desert under crystal clear skies, watching scientists point telescopes toward the heavens. In rural India, families huddle around radios, listening to broadcasts describing the strange visitor. In cities across the globe, school children and adults alike look upward, sharing a moment of universal connection to a single, mysterious object hurtling through space. And as 3I/Atlas continues its approach, the tension builds. Every rotation of the tumbling object exposes new surfaces, sending back varying reflections of sunlight and subtle shifts in the signal. Astronomers are noting slight changes in amplitude, suggesting fragments may be breaking off, or that the object's composition varies across its surface. Each change brings renewed scrutiny, renewed speculation, and renewed wonder. The pulse of humanity matches the rhythm of the object itself, a global audience holding its collective breath. Tonight, as I speak, 3I/Atlas is no longer just a distant visitor. It has become a shared experience, a cosmic event witnessed by billions in real time. Scientists, governments, enthusiasts, and the general public are all participants in a single unfolding story. No one can predict what will happen next, whether the signals are natural, artificial, benign, or intentional. And yet, one truth is undeniable. Humanity has never looked at the sky in quite this way before. This is Kai Mercer speaking live as the signals from 3I/Atlas continue to arrive, as the object draws closer, and as the world waits, united by curiosity, uncertainty, and the profound realization that we are not alone in the vastness of space. This is Kai Mercer, speaking to you live as an extraordinary event unfolds above our heads. Observatories across the globe are reporting something unprecedented. The interstellar object 3I/Atlas, already a remarkable visitor from beyond our solar system, is now changing color as it approaches Earth. At first, the change was subtle. Sensitive instruments detected a shift in the wavelengths reflected by the object's surface, from a pale, icy white to a soft, almost metallic blue. But as additional observations poured in, the transformation became unmistakable, sweeping across the object's jagged, tumbling fragments. What had once appeared as a simple, rocky, icy body now glowed in hues that no natural comet or asteroid should exhibit. Astronomers are baffled. Spectroscopy data, carefully analyzed by teams in Chile, Hawaii, and Spain, show irregular fluctuations in the reflected light. Some areas of the object appear to absorb certain wavelengths while reflecting others, creating a dynamic spectrum that is changing in real time. Scientists are scrambling to explain the phenomenon. Could it be caused by interactions with the solar wind, the sudden exposure of volatile materials, or something entirely unknown? There is no precedent in astronomical records for a body from interstellar space to exhibit such vivid, rapidly shifting colors. Meanwhile, the global response is immediate and electrifying. Across continents, telescopes, both professional and amateur, have captured images of the changing hues. In rural Japan, families watch together as the pale blue glow seems to shift to greenish tones under the evening sky. In South America, students in observatories cheer as the object's fragments reflect sunlight in flashes of red and amber. Social media is ablaze with live photos, videos, and animated simulations as the public witnesses a phenomenon that is simultaneously breathtaking and incomprehensible. Space agencies are treating this event with the utmost seriousness. Scientists at NASA, ISA, and JAXA are convening round-the-clock meetings, analyzing real-time spectroscopic data and refining trajectory models to account for unexpected forces. Could the color change indicate chemical reactions, outgassing, or surface metamorphosis? Or is it evidence of a more unusual process, perhaps something artificial, a feature of an unknown interstellar object? Experts are cautious, emphasizing that while speculation is tempting, careful analysis is required. In observatories, the tension is palpable. Researchers are adjusting filters, recalibrating instruments, and cross-referencing data from multiple hemispheres. The phenomenon is not uniform. Different fragments are displaying different colors, rotating independently, creating a surreal, almost alien kaleidoscope in the sky. Every observation raises new questions. How can a single body, millions of kilometers away, shift its reflected light so dramatically in real time? Could it be an interaction with cosmic rays, a sudden phase change in its materials, or something else entirely? Public imagination has been captured like never before. News networks across Europe, North America, and Asia are dedicating prime-time coverage to live updates. Citizens in cities and towns alike pause to watch the sky, their attention riveted by the changing spectacle. The combination of science and wonder has created a global moment of shared awe. People are looking upward together, trying to interpret what they see. For a brief moment, Earth feels united under a single celestial event. Meanwhile, radio and optical instruments continue to detect the familiar pulses from 3I/Atlas, the enigmatic signals we first reported when the object began approaching Earth. Some teams are now speculating that the color changes may correlate with variations in the electromagnetic signals. Could this be a form of communication, a natural process, or an entirely unknown phenomenon? The data is incomplete, but the patterns are striking enough that scientists are calling for urgent collaboration across continents. As the object continues to approach, its colors grow more intense and unpredictable. Pale blues deepen to vibrant cyan, patches shift to faint orange, and glimmers of violet appear along jagged edges. Each rotation exposes a new palette, as if the object itself were alive, responding to some unseen force. Observatories are broadcasting the phenomenon in real time, allowing researchers and the public alike to witness the unprecedented spectacle. For now, the object remains a safe distance from Earth, though it continues to enter our immediate cosmic neighborhood. The changes in color, combined with its tumbling motion and the persistent signals, have transformed 3I/Atlas from a scientific curiosity into an object of profound global interest. Across the world, scientists, enthusiasts, and casual observers alike are asking the same question. What exactly are we witnessing? Tonight, as we watch, record, and analyze, one truth is undeniable. Humanity is witnessing the unknown unfold before our eyes. 3I/Atlas, a fragment from a distant star system, has become more than a mere object in space. It is a living, dynamic spectacle, a reminder of the vastness, mystery, and unexpected beauty of the universe. This is Kai Mercer, Speaking live as 3I/Atlas continues its approach, changing color and sending signals across the void. History is happening above us, and for the first time, we are watching it in real time. This is Kai Mercer, coming to you live as 3I/Atlas reaches the final leg of its journey through the inner solar system. Observatories across the globe confirm what astronomers have been tracking for weeks. The interstellar object is now within a few million kilometers of Earth, moving faster than anything we've ever measured in our skies. Its approach is steady, precise, and, as recent observations show, far more dramatic than anyone could have predicted. The color changes that began days ago have intensified. Through telescopes, fragments of the object now glow in vivid hues. Bright cyan, amber, and flashes of violet sweep across the tumbling body. Each rotation reveals new surfaces, reflecting sunlight in unexpected ways. Scientists are scrambling to calibrate their instruments, capturing data as fast as they can. There is no precedent for such dynamic behavior from a natural interstellar object. Every new frame, every new spectrum, raises more questions than answers. And the signals, the electromagnetic pulses we first reported, are stronger than ever. Radio telescopes record sudden bursts of coherent patterns that appear to vary in sync with the color shifts. Analysts are working frantically to interpret them, running advanced algorithms and simulations to see if a message, intentional or otherwise, might be encoded in the fluctuations. The phenomenon is unlike anything humanity has witnessed. A celestial body that not only moves across space, but also seems to communicate in a language we cannot yet understand. Across the globe, the public watches in awe. In major cities, people have gathered on rooftops and in open fields to catch glimpses of the object's glow through amateur telescopes. In rural areas, communities huddle around radio broadcasts describing the live observations, hanging on every word as Kai Mercer narrates the unfolding events. Social media is flooded with images, videos, and live commentary, creating a global audience united in curiosity, excitement, and, for some, fear. On the scientific front, emergency coordination centers have been activated. Teams at NASA, ESA, and other international agencies are analyzing potential outcomes, calculating gravitational interactions, and monitoring the object's rotation and fragmentation. So far, all projections indicate no direct collision with Earth, but the close approach will allow unprecedented observation opportunities. Every second counts, and every fragment is being tracked. And then, just as predicted, the object begins to pass its closest point. Observatories report rapid, spectacular changes in both color and brightness. Some fragments scatter along the trajectory, reflecting sunlight like tiny fireworks against the black canvas of space. The main body, massive and jagged, casts an almost ethereal glow as it sails past Earth at breathtaking speed. The pulses in the electromagnetic spectrum spike in intensity, creating a pattern that some analysts suggest may resemble sequences of prime numbers, repeating structures, or other signs of coherence. Whether intentional or natural, the phenomenon is undeniably complex. Globally, the tension reaches a peak. People hold their breath as the closest fragments skim past the moon's orbit. Amateur astronomers record images in real time. Professional observatories beam live feeds to command centers and science institutions. Scientists offer calm, reasoned commentary, but even their faces betray a mixture of exhilaration and disbelief. This is the first time in recorded history that humanity has observed an object from another star system so intimately, so dynamically, and so vividly. The object now recedes, moving away from Earth as quickly as it approached. Color patterns shift again, fading from vibrant cyan and violet to pale amber and white, leaving behind a scattering of fragments trailing along its path. The electromagnetic signals slowly weaken, though some pulses continue, hinting at patterns yet to be fully understood. Telescopes continue tracking, but the intensity of the moment begins to settle into reflection and analysis. Tonight, humanity has witnessed an event that will be remembered for generations. 3I/Atlas has passed within our cosmic neighborhood, a visitor from the depths of interstellar space that challenged everything we thought we knew about the universe. It brought with it color, motion, and signals that hint at mysteries far beyond our current understanding. And though it moves onward into the void, it leaves behind questions, data, and a profound reminder. The universe is vast, unpredictable, and alive with wonders we are only beginning to perceive. This is Kai Mercer speaking live as 3I/Atlas recedes into the darkness, leaving humanity both humbled and inspired. Tonight, we have touched the edge of the unknown, and in that moment, we are forever changed. This is Kai Mercer, speaking to you as the world begins to sift through the data left behind by 3I/Atlas. In the hours since its closest approach, scientists have been poring over the electromagnetic pulses recorded from the object, analyzing them with some of the most advanced radio telescopes ever constructed. What was once faint and intermittent is now a rich data set, offering the possibility, however slim or extraordinary, that these signals may contain structure, complexity, or information unlike anything we have observed from a natural source. Teams in Chile, Hawaii, and Europe are working around the clock. Using computational models and signal processing algorithms, they are searching for patterns, repetition, modulation, and sequences that could hint at encoding. Some of the initial findings are astonishing. The pulses are not random. They exhibit subtle periodicity with intervals that seem mathematically significant. Analysts are comparing them to known cosmic phenomena, natural radio bursts, and even pulsar patterns, yet nothing matches exactly. The signals are unique, suggesting that whatever process created them is not part of the catalog of natural astrophysical events. Spectral analysis has revealed additional layers of complexity. The pulses appear to carry multiple frequency bands simultaneously, shifting in amplitude and phase over time. Some researchers note correlations between the pulses and the color shifts observed as 3I/Atlas passed near Earth. Could these color changes and electromagnetic variations be linked, part of a single process, or even a form of signaling? The scientific community is careful. Correlation does not prove causation, but the evidence is tantalizing. Experts are also exploring the possibility that these signals may represent structured numerical sequences. Initial models suggest patterns that align with prime numbers, Fibonacci sequences, or other mathematical constructs. While the data is incomplete, the repeated intervals and coherence in the pulses are compelling enough to inspire intense debate. Are these patterns simply the result of unknown natural physics, or could they be evidence of intelligent design? For now, the answer remains elusive, and scientists emphasize that extraordinary claims require extraordinary proof. Meanwhile, observatories continue to monitor fragments of 3I/Atlas as they drift along its post-approach trajectory. Even in these smaller pieces, faint electromagnetic activity persists. Researchers are cataloging each fragment, tracking any subtle variations in signals, and cross-referencing with their original datasets. The complexity of the system is staggering, a tumbling, fragmenting body from interstellar space, reflecting light in shifting colors, and sending signals that defy easy explanation. The global scientific community has responded with unprecedented collaboration. Teams from multiple countries are sharing data in real time, publishing raw signal files for independent verification, and running simulations to test every plausible natural explanation. The atmosphere is one of careful exhilaration, a mix of skepticism, excitement, and the recognition that humanity is witnessing something extraordinary, something at the edge of our understanding. Public interest remains high. News outlets broadcast updates from scientific teams, highlighting the meticulous work underway. Online communities analyze and discuss open data, sometimes speculating wildly, but always returning to the core question. Could 3I/Atlas have been more than a visitor from the stars? Could these signals, in some way, be a message? Scientists repeatedly caution that interpretation is premature. Yet even within this restraint, there is a palpable sense of awe, a recognition that we are glimpsing a phenomenon entirely unlike anything previously encountered. As data analysis continues, theoretical models expand. Some researchers propose that the signals could be caused by complex chemical or physical reactions on the object's surface, interacting with solar radiation in unusual ways. Others explore more speculative scenarios, guided probes, interstellar artifacts, or even remnants of an intelligence far older and more advanced than our own. For now, these remain hypotheses. But as the world observes, listens, and analyzes, 3I/Atlas has already accomplished something remarkable. It has united humanity in a single, shared encounter with the unknown. Tonight, as I speak, the signals continue to be dissected, patterns teased from the noise, and theories debated in laboratories across the globe. Whether natural or artificial, benign or intentional, these pulses mark a turning point, a reminder that the universe contains surprises, mysteries, and possibilities beyond our imagination. 3I/Atlas has passed, yet it leaves us with data, questions, and the thrilling knowledge that the stars may have something to say. If only we can learn to listen. This is Kai Mercer, speaking live as scientists continue their painstaking work, decoding the whispers of an interstellar visitor that has forever changed our perspective on the cosmos. This is Kai Mercer, coming to you live as the world braces for what may be the most profound scientific endeavor in human history, attempting to decode the signals sent by 3I/Atlas. Following its closest approach, the interstellar object has left behind a stream of electromagnetic pulses that continue to intrigue, perplex, and inspire scientists across the globe. Tonight, laboratories from Chile to Japan, from Europe to the United States, are operating around the clock, analyzing these enigmatic signals with cutting-edge supercomputers and the brightest minds in astrophysics, mathematics, and information theory. The first step has been to separate signal from noise. Cosmic radiation, solar flares, and terrestrial interference all contribute to background static, making it a monumental challenge to isolate coherent patterns. But early analyses show recurring sequences, repeated intervals, and structures that are difficult to explain as natural phenomena. Some researchers report that certain pulses repeat in a rhythm reminiscent of prime numbers, a pattern often suggested as a universal sign of intelligence. Others note subtle frequency shifts, almost as if the object's tumbling motion is modulating the pulses, adding layers of complexity. Across observatories, tension is palpable. Teams are sharing raw data openly, running independent checks to ensure the integrity of the findings. Algorithms attempt to map the sequences into visual or numerical representations, converting the signals into graphs, spectra, and binary-like sequences. Even preliminary results are striking. Patterns emerge that appear too structured to be random, yet too intricate to offer immediate meaning. Every small breakthrough is met with a combination of caution and exhilaration. Meanwhile, global reactions reflect the stakes of this discovery. In major cities, citizens gather in science museums, planetariums, and public viewing centers, following live feeds as data streams in. Social media is ablaze with speculation. Some celebrate the possibility of the first message from beyond our solar system, while others express anxiety at the unknown implications. News anchors carefully relay updates from observatories and space agencies, emphasizing the scientific rigor behind the effort, while acknowledging the unprecedented nature of the event. Humanity, in this moment, is united in a shared experience of wonder, curiosity, and the fragile excitement of discovery. Back in laboratories, researchers attempt more sophisticated approaches, breaking down the pulses into possible encoding schemes, looking for repetitions in prime number sequences, Fibonacci-like ratios, and binary structures. Teams model the way the object's rotation, fragmentation, and color changes might have modulated the signals. Some scientists cautiously speculate that the correlation between color variation and signal fluctuations could be a method of visual or multi-frequency communication, an interstellar Morse code encoded in both light and radio waves. The philosophical implications are immense. While scientists stress caution and rigor, ethicists and philosophers weigh in on what it would mean if the signals are indeed intentional. How should humanity respond? Can we even interpret a message from a civilization that may be thousands or even millions of years more advanced than our own? Across the globe, conversations are unfolding about the nature of intelligence, the limits of our understanding, and the possibility that the universe is not as silent as we once believed. Late into the night, as the analysis continues, tantalizing sequences appear, bursts of information that some researchers describe as structured but undecipherable. Teams attempt cross-referencing with known mathematical constants, natural physical patterns, and linguistic models. Nothing provides a definitive translation, yet the very presence of structured complexity fuels both excitement and debate. The signals challenge our assumptions. They are precise, intentional in appearance, yet enigmatic, demanding patience, collaboration, and humility. For the public, the spectacle is both scientific and emotional. Across continents, people watch as telescopes capture the last fragments of 3Y/Atlas, glowing faintly as they drift into space, while laboratories decode its invisible message. Social media threads are filled with speculation, awe, and philosophical reflection. Live broadcasts feature interviews with scientists describing the painstaking work underway, providing a rare glimpse into the human effort behind cosmic discovery. Tonight, humanity stands at a threshold. 3I/Atlas has left behind signals that may carry knowledge, information, or meaning. Or they may simply be a natural, beautiful mystery. Yet the act of listening, analyzing, and attempting to understand these pulses is itself a transformative moment. We are no longer passive observers of the cosmos. We are participants in an unfolding dialogue, a bridge of curiosity between our world and the stars. This is Kai Mercer, speaking live, as scientists continue to decode the enigmatic signals of 3I/Atlas. History is unfolding in real time, and humanity, for the first time, is listening to a voice that may not originate from Earth. Tonight, we wait, we calculate, and we wonder, together. This is Kai Mercer speaking to you live as humanity attempts to unravel one of the most extraordinary phenomena in recorded history. In the hours since 3I/Atlas's closest approach, Laboratories around the world have been analyzing the interstellar object's electromagnetic pulses with unprecedented intensity. What began as faint, irregular bursts are now revealing patterns that are drawing both excitement and caution from scientists. The first breakthrough came just hours after the object's passage. Supercomputers in Chile and Hawaii identified recurring intervals in the signals, subtle periodicities that appeared too structured to be random. Mathematicians and astrophysicists immediately began cross-referencing these intervals with prime numbers, Fibonacci sequences, and known natural pulsar timings. While no direct translation is yet possible, the regularity is remarkable, far beyond what one might expect from cosmic noise or random interactions with solar wind. As the signals are analyzed, their complexity becomes ever more apparent. Layers of modulation appear across multiple frequency bands. Some pulses are extremely short, lasting mere milliseconds, while others stretch across seconds, creating intricate overlapping sequences. In laboratories, researchers are creating visual maps of the signals, turning them into flowing graphs of light and color to better identify recurring motifs. The patterns are almost musical in nature, with peaks and troughs that hint at deliberate structure, though their meaning remains elusive. Meanwhile, 3I/Atlas itself continues to fade into the distance. Observatories across the world are capturing the last of its fragments as they scatter along its trajectory, glowing faintly in hues that now shift more slowly. Blues, violets, and pale ambers fading into darkness. Yet even as the object recedes, the signals persist. They continue to arrive at our instruments with remarkable clarity, a reminder that the object may have left more than debris. It may have left a trace of intent, a cosmic message waiting to be understood. Globally, the reactions are unprecedented. In Europe, large screens in observatories display live data feeds from radio telescopes as scientists narrate their findings. In the United States, classrooms, planetariums, and science centers host live broadcasts, allowing students and the public to watch in awe. Social media is ablaze with speculation. Diagrams, animations, and raw data are shared widely, fueling debates about whether the signals are natural or artificial. Across Asia, millions tune in to local broadcasts, mesmerized by the possibility that the universe is attempting to communicate with us. Inside the laboratories, the tension is almost tangible. Teams of astrophysicists, signal analysts, and mathematicians work through the night. Some focus on the timing of pulses, others on frequency shifts, and yet others attempt to correlate the electromagnetic patterns with the color changes observed as 3I/Atlas passed near Earth. Could the object's rotation, tumbling motion, and surface composition have modulated the signals in a meaningful way? Researchers debate every anomaly, knowing that any small insight could represent humanity's first contact with an interstellar intelligence, or a profound, natural mystery unlike anything previously encountered. Ethicists and communication theorists have also joined the conversation. If the signals are deliberate, how should humanity respond? Should we attempt to reply, even in the absence of a clear translation? International committees convene virtually, weighing risks and protocols. Some argue for caution, pointing out that we cannot yet ascertain the intent, nature, or even origin of the signals. Others insist that any opportunity to communicate across interstellar distances must be explored, even if only to acknowledge the receipt of the message. As the hours progress, subtle new patterns emerge. Certain sequences recur with near mathematical precision. Analysts notice correlations between these sequences and earlier bursts that occurred during the object's closest approach. Could these be attempts at synchronization, a method of encoding meaning over time? Every simulation, every cross-reference strengthens the mystery, while also building the first tantalizing hints of potential comprehension. Outside the scientific community, public interest is both rapt and anxious. In cities around the world, people gather on rooftops, in parks, and at public screenings. Families, students, and curious citizens watch the sky or follow live streams, sharing the sense of witnessing something larger than themselves. Philosophers, theologians, and writers weigh in on the implications, exploring questions about the nature of intelligence, the possibility of life beyond our solar system, and humanity's place in the cosmos. For a brief moment, the world is united by wonder and curiosity. In laboratories, the painstaking work continues. Teams are now attempting translation protocols, converting pulse sequences into binary, mapping them into grids, and analyzing them for recurring structures. Early visualizations suggest repeating geometric patterns, almost like abstract symbols, though their meaning remains unresolved. Some researchers caution that human brains are naturally predisposed to find patterns, warning against hasty conclusions. Yet the evidence is compelling enough to inspire hope, that within these pulses, hidden amid the apparent randomness, could be a message, or at least the first glimpse of an interstellar mind at work. As the night deepens, the world watches and waits. Observatories remain open, instruments remain active, and scientists remain vigilant. The signals, though mysterious, offer a sense of continuity, a reminder that 3I/Atlas was not just a fleeting visitor, but a bridge between our world and the wider cosmos. Humanity is listening more closely than ever, poised to decipher whatever the universe may be attempting to share. And in this moment, as calculations continue, signals are analyzed, and patterns are traced across radio waves, one fact is clear. For the first time in history, we are not alone in the act of discovery. Whether the pulses of 3I/Atlas contain meaning, intelligence, or simply the exquisite complexity of the cosmos, we are participants in a dialogue that transcends time, distance, and imagination. This is Kai Mercer speaking live, as scientists across the globe continue their historic work, decoding the enigmatic signals of 3Y/Atlas. Tonight, we are witnesses to a message that may have traveled light years to reach us, and the possibilities it holds are as vast as the universe itself. Humanity listens, analyzes, and wonders, and in doing so, we step onto a threshold that may forever redefine our understanding of life, intelligence, and the cosmos. This is Kai Mercer speaking live as 3I/Atlas continues to captivate the world. And tonight, new developments are raising both excitement and concern. Observatories across the globe have just reported that the interstellar object is accelerating unexpectedly. Its velocity, already extraordinary, is now increasing at a rate that has taken scientists by surprise. While previously predictable within narrow margins, the comet is now moving faster than projected, pushing the limits of current trajectory models. Even more astonishing, slight deviations from its original path have been detected. The object, once following a smooth curve through the inner solar system, is now veering subtly, though measurably, from its anticipated course. Analysts are scrambling to determine whether this is due to natural forces, perhaps asymmetric outgassing from volatile ices, or something entirely different. Whatever the cause, the shift has global observatories adjusting telescopes and recalculating orbital projections in real time. Across research centers, tension is palpable. Teams in Chile, Hawaii, Japan, and Germany are collaborating non-stop, updating models with every new observation. The speed increase is small in absolute terms, yet significant enough to alter predictions of how 3I/Atlas will pass relative to Earth. Even the smallest change in trajectory at these velocities can have enormous implications for close approach calculations and fragment dispersion. Every fragment, every tumbling piece is being tracked with laser-like precision. The color changes that were so mesmerizing over the past few days continue, now shifting more rapidly as the comet accelerates. Cyan, violet, amber. The hues ripple across the object's surface in unusual patterns, almost as if responding to forces we cannot yet explain. Observatories record fluctuations in brightness and surface reflection, and scientists are debating whether the changes could be linked to structural stress, uneven outgassing, or some deeper unknown mechanism. Whatever the cause, the visuals are stunning, and the data is unprecedented. Meanwhile, the electromagnetic signals continue unabated. In fact, some analysts report subtle changes in timing and modulation that correlate with the comet's acceleration. Could the speed increase be natural physics at work, or could it be influencing or even generating the signals? The questions grow more urgent as researchers attempt to parse milliseconds of variation in the pulses, seeking patterns that might hint at intent or structure. Globally, the public is riveted. News outlets interrupt programming to broadcast live telescope feeds, showing fragments streaking across the sky. Social media is filled with images and amateur videos as people attempt to capture the accelerating, color-shifting comet with anything from smartphones to backyard telescopes. In schools, planetariums, and public observatories, crowds gather to watch the object move faster than anticipated, aware that they are witnessing a once-in-a-lifetime cosmic event. Emergency coordination teams at space agencies have doubled their analysis efforts. NASA, ESA, and JAXA are modeling possible trajectories with extreme precision, factoring in the unexpected acceleration and slight course changes. Even though no impact is currently predicted, the deviation has heightened the need for constant monitoring. Scientists are calculating potential fragment paths, debris dispersion, and variations in orbital velocity, knowing that even a minor miscalculation could affect predictions of how Earth's space environment will be influenced. In laboratories, theorists and engineers discuss potential explanations. Some suggest that sublimation of exotic ices or internal gas pockets may be providing thrust, causing acceleration and a subtle shift in orientation. Others are more cautious, acknowledging that the behavior of interstellar objects is largely unknown, and that the combination of speed, color change, and signal emission may hint at processes we have never observed. The debate is rigorous, detailed, and ongoing, the hallmark of science at the edge of discovery. As I speak, 3I/Atlas continues its rapid approach, tumbling, accelerating, and subtly curving through space. Its passage reminds humanity of the unpredictable power and mystery of the cosmos. Across the globe, scientists, enthusiasts, and the public alike are united in a shared gaze toward the heavens. The comet is no longer just a visitor. It has become a dynamic presence, alive in motion, color, and signal, challenging our understanding of physics and perhaps even of communication itself. This is Kai Mercer, reporting live as 3I/Atlas accelerates past our expectations and shifts its course just enough to remind us that the universe is rarely predictable. We continue to monitor, calculate, and observe, fully aware that we are witnessing history in motion, and that each passing second brings new discoveries, new questions, and a deepened sense of awe at the cosmic unknown. This is Kai Mercer, speaking live as humanity witnesses a moment that will be remembered for generations. Tonight, 3I/Atlas, the interstellar visitor that has captivated the globe for weeks, is passing closest to Earth. Its speed has increased unexpectedly. Its trajectory shifted slightly, and fragments of the object are scattering across the sky, catching sunlight in dazzling displays visible through telescopes worldwide. The event is unfolding in real time, and the world is holding its collective breath. Observatories report that the fragments are reflecting sunlight in brilliant, fleeting glimmers. Cyan flashes, amber streaks, and violet sparks ripple across the object's tumbling body as it spins at immense velocity. Some smaller fragments, heated by the sun, are vaporizing in micro-explosions, creating a subtle trail of glowing particles. Telescopes from Hawaii to Chile to the Canary Islands capture these fragments in high-resolution, streaming images that are mesmerizing, almost otherworldly in their beauty. Scientists marvel at the spectacle, yet their minds race to track each piece and calculate its trajectory. And then there are the signals. The electromagnetic pulses that began as faint and mysterious are now intensifying dramatically. Their frequency shifts in real time, synchronized with the comet's tumbling rotation and subtle trajectory changes. Analysts report that the modulation is more structured than ever, almost as if the object is responding to its environment. Some sequences appear in repeating clusters, suggesting an underlying system or design, patterns that tantalize scientists but resist interpretation. Across radio observatories, excitement and tension crackle in equal measure. Globally, the response is electric. In major cities, people gather under clear night skies, binoculars and amateur telescopes in hand. Families huddle on rooftops, neighbors point and gasp as fragments of 3I/Atlas streak across the heavens. Social media explodes with images, videos, and live commentaries. In schools and planetariums, educators narrate the event for students, blending physics, astronomy, and philosophy in a single breath. The public is witnessing not just a celestial object, but the unfolding of a cosmic drama, a story written in light, motion, and pulses from the depths of space. Inside research centers, tension has reached a fever pitch. Scientists at NASA, ESA, JAXA, and other agencies are simultaneously tracking the object's trajectory, analyzing fragments, and decoding signals. Every fragment is cataloged, every pulse scrutinized. Models are updated by the second to account for the acceleration and course deviation. Some fragments skim the edge of Earth's upper atmosphere, interacting with it just enough to create faint ionization trails visible in radio instruments. No immediate danger is detected, but the complexity of the system pushes even the most advanced simulations to their limits. Observers report that some of the fragments appear to flash in patterns, sudden bursts of light synchronized with peaks in the electromagnetic signals. Could this be coincidental, a product of sunlight reflecting off rotating surfaces? Or is it a form of deliberate signaling, a communication encoded across both light and radio waves? The possibility electrifies labs, with teams working frantically to correlate the flashes with the pulse sequences. Every microsecond counts, as the comet hurtles past Earth at speeds impossible for any human-made probe. Public tension mirrors the scientific urgency. Some viewers are awestruck, marveling at the beauty and rarity of the event. Others express anxiety, a natural reaction when the cosmos behaves unpredictably before our eyes. News anchors speak in hushed, urgent tones, conveying the significance of the moment without sensationalism, while citizens in remote locations report seeing fleeting glimmers in the night sky, adding eyewitness data to the global record. For a brief period, humanity is unified in attention and emotion, collectively witnessing an encounter with the unknown. As the closest approach passes, The fragments continue to streak outward, scattering along trajectories shaped by the object's rapid spin and subtle course shift. The signals reach peak intensity, patterns more structured than ever, pulsating across radio bands with clarity and strength. Laboratories decode sequences into visual and numerical representations, attempting to discern repetition, ratios, and structure. Even partial analyses hint at something deliberate, a complexity beyond known natural processes. The world watches as science pushes to its limits in real time, striving to extract meaning from the cosmic pulses. Slowly, 3I/Atlas begins to recede, moving away from Earth, its fragments trailing a fading glow in the sky. Color changes diminish, flashes of light become sporadic, and signals weaken but do not vanish entirely. Scientists continue their observations, recording every detail, knowing that even as the comet moves into the distance, the legacy of its passage, the data, the signals, the questions, will occupy humanity for years, decades, perhaps centuries. Tonight, the cosmos has spoken in ways that defy simple explanation. 3I/Atlas has passed within our neighborhood, a visitor from another star system, scattering fragments, color, and signals across the sky. Humanity has witnessed it, recorded it, and listened intently. The object leaves behind more than debris. It leaves questions, inspiration, and the knowledge that the universe contains mysteries beyond our current understanding. This is Kai Mercer, speaking live as 3I/Atlas recedes into the void, leaving a world forever changed by a close encounter with an interstellar visitor. History has been made tonight, in light, in signals, and in the awe that reminds us how small, and yet how profoundly connected, we are to the cosmos. This is Kai Mercer, speaking to you live as the interstellar visitor that has captivated the world begins its slow retreat from our planet's neighborhood. 3I/Atlas, which once blazed across the night sky in dazzling flashes of cyan, amber, and violet, is now drifting away, its tumbling fragments scattering into the darkness of space. Each rotation of the main body reveals less and less light, the vibrant flashes fading like embers in the vast cosmic night. Observatories continue to track every fragment, yet even the most powerful telescopes show a steady dimming. The comet's color changes, once vivid and intense, are now subtle, almost imperceptible. Spectral data reveal a softening of reflected light, a gentle decrease in intensity as the object recedes toward the edge of detectability. Its velocity remains high, but the apparent motion from Earth's perspective slows, giving the impression that the object is drifting deliberately into the void, leaving behind a sky that now seems quieter, emptier, yet charged with the memory of its presence. The electromagnetic signals that thrilled and puzzled scientists for weeks are also fading. The pulses that once displayed remarkable structure and intensity now arrive sporadically, weaker but still discernible. Analysts are racing to capture every last sequence, to preserve data that may hold the key to understanding the object's origin, composition, or even its potential intelligence. Even as signals weaken, the complexity remains. Each pulse, however faint, is a whisper from an interstellar traveler that has crossed unimaginable distances to reach our solar system. Globally, the sense of awe and melancholy is palpable. In cities and towns, people pause to watch the night sky, aware that the bright, dynamic spectacle they had witnessed is now disappearing. Amateur astronomers capture the last glimpses of glowing fragments, while students and families gather in observatories and planetariums to witness the final act of a cosmic performance. Social media quiets slightly, but the images and videos already shared continue to circulate, a digital record of a celestial event that was both fleeting and unforgettable. In research centers, scientists reflect on the data collected, analyzing the patterns of color, motion, and electromagnetic pulses one final time. Discussions are now tempered with a sense of closure, even as new questions emerge. What was the true nature of 3I/Atlas? Were the signals natural, or were they a form of communication? Did the color changes reveal unexpected chemistry or structural phenomena? The object may be vanishing from our view, but its mysteries remain, a puzzle left in the minds of humanity. As the comet recedes, the fragments grow ever smaller in telescopic images, each one like a distant star drifting into the cosmic sea. The main body itself fades into near invisibility, a ghostly remnant of an interstellar journey that has briefly intersected with our own. Observers note that the remaining light shifts subtly with each rotation, a faint shimmer that soon disappears entirely, leaving the night sky as it was before, vast, quiet, and immeasurably deep. And yet, the impact of 3I/Atlas lingers. Scientists, educators, enthusiasts, and casual observers alike are left with data, memories, and a renewed sense of connection to the cosmos. The event has united humanity in shared observation, in wonder, and in a profound awareness of the universe's scale and mystery. The comet may vanish from sight, but its legacy endures in the questions it raised, the beauty it revealed, and the reminder that we are part of a universe far larger than ourselves. Tonight, as we watch 3I/Atlas drift beyond the reach of our telescopes, one thing is clear. Its journey continues, and though unseen, it carries with it the story of a brief but extraordinary encounter. Humanity has witnessed a visitor from beyond the stars, and while it disappears into the darkness, the echoes of its passage will be felt for generations to come. This is Kai Mercer speaking live as 3I/Atlas fades into the void, leaving a world forever changed and a sky forever richer for having been touched by the light of an interstellar traveler. This is Kai Mercer speaking live as the final traces of 3I/Atlas vanish into the vast void of space. Over the past days, we have watched, recorded, and analyzed one of the most extraordinary events in human history. What began as a distant point of light in the night sky transformed into a breathtaking spectacle of motion, color, and mystery, leaving a legacy that will echo through science, philosophy, and the human imagination for generations. From the moment it was first detected, 3I/Atlas defied expectations. Its tumbling trajectory, the sudden shifts in velocity, the dazzling color changes, and the enigmatic electromagnetic pulses captured the attention of observatories and research centers worldwide. Teams from Chile, Hawaii, Japan, Europe, and North America worked around the clock, sharing data, cross-verifying observations, and building the most comprehensive record of an interstellar object in human history. Every fragment, every flicker of reflected sunlight, and every millisecond of signal was cataloged, analyzed, and preserved. A treasure trove for scientists who will study this visitor for decades, seeking to understand its origins, its composition, and the remarkable phenomena it exhibited. The signals themselves were among the most puzzling and exciting aspects of the event. Electromagnetic pulses, once faint and irregular, became increasingly structured, revealing patterns that continue to intrigue astrophysicists and signal analysts. While no definitive translation has yet been achieved, the repeated intervals, complex modulations, and apparent correlations with surface color changes hint at a level of order far beyond what is expected from a typical interstellar comet. Whether the pulses are a product of natural physics, chemical interactions, or something more, perhaps even intentional, remains unknown. And yet, in their mystery, they have inspired humanity to listen more closely to the universe than ever before. Public fascination with 3I/Atlas has been profound and global. Across continents, millions of people witnessed the comet's passage, some through high-powered observatories, others with amateur telescopes or even binoculars from their backyards. Families, students, amateur astronomers, and casual stargazers alike shared in the wonder of the event. For days, social media was filled with images, videos, and live commentary from around the world. Cyan flashes, amber streaks, violet glimmers, fragments scattering in the darkness, and the faint trails of light slowly fading as the object receded. Conversations shifted from the everyday to the cosmic, as humanity collectively grappled with the scale, beauty, and mystery of what we had just witnessed. Philosophers, ethicists, and thinkers have joined the discussion, reflecting on the meaning of encountering a visitor from beyond our solar system. Was 3I/Atlas simply a remarkable natural object? Or might it carry the traces of intelligence encoded in its signals and motion? Could the color changes and electromagnetic pulses be a form of communication? Or are we interpreting patterns where none were intended? Even without a definitive answer, the very act of listening, of striving to understand, has connected us to the universe in ways that are both humbling and inspiring. As the final fragments fade from sight, drifting silently into the void, and as the pulses weaken to near imperceptibility, we are reminded of the fleeting nature of such encounters. The night sky, once filled with dazzling activity, grows quiet again. Yet the memory of color, light, and signals lingers, etched into our minds, our instruments, and the collective memory of humanity. It is a reminder that, even in the vast emptiness of space, moments of extraordinary connection are possible. Moments that remind us of our smallness, our curiosity, and our place in the cosmos. In observatories and laboratories, scientists continue to examine the data, even now. Every pulse is stored, every trajectory logged, every fragment mapped. The work will continue for years as models are refined, simulations rerun, and interpretations debated. 3I/Atlas has left behind questions as profound as the universe itself. What is the nature of interstellar objects? What can their behavior teach us about physics, chemistry, and possibly communication? And what does it mean for humanity to encounter a visitor from the stars? Meanwhile, across the world, the public reflects. People remember the awe of watching fragments streaking across the sky, the fleeting bursts of color, the knowledge that signals from a distant traveler may have reached our instruments. In homes, classrooms, and public spaces, communities share stories, images, and reflections. The event has become more than science. It has become a shared human experience, a moment when our attention collectively turned outward, toward the unknown. And now, as 3I/Atlas recedes beyond the reach of our telescopes and the last pulses fade into silence, the experience becomes both memory and inspiration. It reminds us of the wonder of exploration, the thrill of discovery, and the infinite mysteries that surround our tiny planet. Humanity has listened, recorded, and observed. We have glimpsed a visitor from another star system and been reminded that the universe is vast, unpredictable, and full of surprises. This is Kai Mercer, speaking live. As we bring this broadcast to a close, I want to thank you for joining us on this extraordinary journey. The light may fade, the signals may grow silent, and the fragments may drift into oblivion, but the experience endures. Remember to look up, to question, to wonder, and to keep listening. For the universe has stories yet to tell, and tonight we have witnessed just one of them. From all of us here at the station, good night. Keep watching the skies, and never forget that the cosmos is always full of mysteries waiting for us to discover.